All right, ladies and gentlemen, welcome back. Hopefully, this is going to be a relatively brief video talking about measuring these characteristics: voltage, current, and resistance of some circuits. And when it gets hands-on, we're going to be using devices like this. And so this guy is called a digital multimeter. I don't know, sometimes you might read or hear it called a DMM. I'm not fond of that term. I just call them meters or multimeters. That's really it. Multi because they're multifunction. This one device can be set up to measure voltage, and there's going to be some wires that plug into these holes on the front, and those wires you have to connect to your circuit in various ways that the details do matter. We'll get to that. You set it up on a different setting on the dial, and you can measure the current flowing through your circuit, or yet another position for resistance of a part of your circuit. So you see how that works. Just the dial is the main control, right? And we also want to put it to the off position where we're not using it. There's a battery inside, and we want to save the battery, so we save the planet, and that's always nice. The panda bears or the polar bears, whichever you prefer. So let's get into this. How about measuring voltage? That's not two T's, that's an L and a T, sorry. And so what's the deal? When you do this with your multimeter, you're going to put it in the voltage measurement setting, and when you do that, you turn it into a voltmeter. That's literally what you'd call it. All right, let's look at a quick circuit here so we can see what's going on. We had a battery, there's a resistor, and we have completed the circuit. Cool. Now, when you connect your voltmeter, what you're going to have to do is you do what's called connecting the voltmeter across part of your circuit. I'll write that down in a moment. So essentially, how do I draw this? I draw a V in a circle, and just say, well, I'm going to connect the voltmeter. Oh my goodness. That's this thing, is the symbol for the voltmeter, and I'm connected across a part of the circuit. That's it. And so let me write that down real quick. So this is something you want to write down. Connect the voltmeter across part of the circuit. So we say across. So it's just like this. Before the battery and after the battery. Okay, so something about voltmeters. You also could connect the voltmeter across a resistor like this. Before and after the resistor. And so here's a few things you know, right? You recognize that current flows out of the positive end of the battery. It flows around your circuit, it comes back into the negative end of your battery. Alright, so and the current flows through this resistor back, and it just keeps going as long as there's juice in the battery, right? So here's the deal. You know that the battery provides energy to the charges. That's what voltage is. It's energy per charge. And so you're talking about a voltage gain right there. And over here, well, what the resistor does is it takes energy away from the charges and does something with the energy. And you get your light, motion, sound. Excuse me. So when that happens, you have a voltage drop. Oh, come on, marker. Voltage drop at the resistor. And you could see, well, does the value there, the value of the drop there. All right. You could also do something like this. You could say, well, what if I want the voltage across the wire right there? You can do this anywhere you want. There's a couple of things you want to write down about this. So when you have hook up your voltmeter, the power will be on. Power on. Okay. And current. Well, does the current from your circuit flow through the voltmeter? No. Current does not flow through the meter. So 3 things to remember about the voltmeter function, right? So here's what's going on. A voltmeter itself, in that setting, has a very, very, very high resistance. So it resists flow going this way. What that does is it forces all the flow through the regular circuit, which is exactly what you want. You really don't want to have to make a measurement, and the measurement changes what's happening here. That's generally frowned upon, right, in polite circles, and so you don't do that. Before we go on, I have a question for you. Okay, so check this out. Battery provides energy to the charges, you see a voltage gain. Resistor takes energy away from the charges, you see a voltage drop. What does the wire do? What do you expect the voltage measurement to be across just the wire? I'll let you think about that. So next, let's talk about current. Measuring current. So when you put your multimeter into the current measurement, see the capital A for like amps, amperes, what you have all of a sudden is an ammeter. A-M-M-E-T-E-R, right there, ammeter. No P. So, how is this going to work? It turns out it's actually different than a voltmeter. Cannot connect it the same way. So we're going to have our circuit. And what I need to do now is I have to not connect across a part of my circuit, but I need to connect within the circuit. In other words, I have to make that ammeter part of the pathway for the current. So how does that happen? What I need to do, let's say, I'm going to take this wire, and I have to sort of interrupt the wire, and I have to put the ammeter in there. And now the current is forced, as it flows out of the battery, is forced to flow through the ammeter. And then it keeps going. So that would tell me the current right here in this section of my circuit. Can I put the ammeter right in the middle of the resistor? No, but what I can do is put the ammeter after the circuit also, after the resistor also. So I could measure the current flowing toward the resistor and the current flowing away from the resistor. And so now that's the current flowing toward the resistor is the current leaving the battery. The current flowing away from the resistor is the current headed toward the battery. So I can get those things. So it's within the circuit, it's part of the circuit, right? That's one thing. Another thing, power is on when you do this. Without the power on and connected, you will get no current, and you just get a reading of 0 amps. Okay, one more thing though. Does current flow through the ammeter? Well, say, duh. Yeah. Current does flow through the ammeter. Well, if it didn't flow through the ammeter, it's not going to measure current for you. So there you go. Easy peasy on the current. The deal is this. With the ammeter function, you set it over here to the setting, whatever setting you like for measuring current. It has just about no resistance in this setting. So it's not going to change the value of the current that's flowing in your circuit. It's not meant to change it, it's just meant to measure it. Alright. Off. Now, we've got voltage, we've got current. The last one to talk about is measuring resistance. Resistance is futile. Now, resistance is measured in ohms. So what you call this now is an ohm meter. You put it in the resistance measurement setting somewhere over here where that little ohm symbol is, and it's now an ohm meter. All right. So now this is really critical that we get a couple things right with the ohm meter function. So let me draw the basic circuit here, and I'm going to add something I haven't used in the past. I'm going to do this, and right here, you know what that is, right? Yep, it's a switch. So look at the position of the switch. There's my resistor, wire, back to my battery. Look at the position of the switch. So it's open. Is this circuit turned on or turned off? Well, will current be able to flow through the switch and get to the resistor? No, it's interrupted, it's broken. So this is the off position. Ladies and gentlemen, that right there is vital. Vital. I'll write that down in just a minute for you. That's super important. So here's what we do. First things first, when you're going to measure with an ohm meter, is only connected across components. So here we see across again. But this is real important. Components that do not produce power. So in other words, it only measures resistors, at least for our purposes. Okay, in this class, you only ever hook up the ohm meter to a resistor, not to a battery, not to a power supply, not to the outlet of the wall, nothing, please. And so that's rule number one. Rule number two, power is off. If you don't do that, you will burn up the ohm meter function in that device, and it will not work, and it cannot be repaired. Not really. If you send too much current through this thing, you're measuring current, you send too much through it, there's a fuse inside, and the fuse blows. Not too bad to replace. Okay, it's not expensive, it's not terribly time consuming, no big deal. The resistance function is not protected by a fuse. It will fry and it will be useless from there on out. So, no, you're not going to break my equipment. No way. I'm teaching you proper here. So, this right here, remember, vital, absolutely. If I do another one and a third, you'll definitely get it.
Marco Sanchez, please dial 4600. Marco Sanchez, 4600, please.
No, there's something else here too. Something else, right? We mentioned it's connected across components that do not produce power. So I want to set this up with a connection with the meter going across a resistor like that. So kind of before the resistor to after the resistor with the power disconnected. Oh my goodness, that is so important. But more than that, I mean, think about this. Well, what if you accidentally say, I'm just going to do this. I'm just going to, on purpose, accidentally, because I want to see Mr. Wood's reaction, I'm going to do that. Connect there and there. No. Please, look. I mean, all you're going to end up doing, do not do this. All you're going to end up doing is it doesn't make any cool sound or smoke or anything like that. It just ruins it. It's broken internally. And I won't like you anymore. So don't do that to my equipment. No. All right. Otherwise, that's about it. You get your measurement. We have measuring voltage. You connect across components. Any component you want, power is on, current generally does not flow through the voltmeter. With current, the connection is different. It's connected within the circuit, made part of the circuit, power is on, current does flow through the ammeter. It's supposed to. And that's cool. And you would want to do stuff like this before the resistor and after the resistor, and you want to make a comparison and learn something from that. And finally, measuring resistance of a component. Connect across the component only if that component does not produce power, so only resistors, and the power in the circuit is off, disconnected, nowhere close to it. Don't even make funny looks at it. No, please. Thank you. Thanks for watching. I'll catch you next time.